Hi everyone, and welcome to the second video out of 3 where we are exploring the two-dimensional array data structure. If you haven't seen the first video, I would encourage you to do so. In that video we looked at how to best picture or imagine a two-dimensional array, and we also looked quite carefully at the way in which Python tends to think, if that's the right way of saying it, tends to think about what a two-dimensional array structure looks like as individual rows where each row comprises a one-dimensional array. So we're going to take those concepts and we're going to take the same table with data as well into this video, and we're actually going to start coding and creating the two-dimensional array version of that table. Now, just for reference, I've put in the block comments, I've put a version of our table from the first video so that we can work with the same data. Excuse me, guys. So what are we going to do first? Well, you may remember in previous videos when we were looking at one-dimensional arrays that I said it was really important to understand how to initialize an empty array. And the same thing applies with two-dimensional arrays as well. On your course, you are required to be familiar with the approach for initializing a two-dimensional array as well. Now, if we go back to the first video where we said rows are king and each row is a one-dimensional array, it won't surprise you, I suspect, to know that we are actually going to start off by initializing a one-dimensional array, which we'll call a row in our table, and we're simply going to repeat the same process of initializing an empty row for each row in our table. So let's do that now, and I'm going to stick with the same naming convention I used in the previous video as well, which was row 0, row 1, row 2, row 3, etc, etc. So let's put a comment in here. Let's say create an initial row. So I'll put in here 1D array because they are the same thing, with empty values. Okay, and I'll put in there none because none is the Python equivalent of emptiness. Okay, so you may remember the syntax from the first of the one-dimensional array videos, where it's essentially none multiplied by the number of times we want to have none in our array. So if we imagine a two-dimensional array, it'll essentially be the number of columns that we have in our table. So we'll say row 0, which is the naming convention I used in the previous video, equals, okay, and then we want our square brackets, we want none in the brackets, and on the outside we want to multiply by 4. Why 4? Because our one-dimensional array, our row in the top of our table, has 4 columns. So in other words, 4 values which we need to initialize with null. And you can see that here actually. It's just an excuse to use my drawing tool. If you look at what essentially we're doing, which is to initialize the first row in our table, we have of course index 0, index 1, index 2, index 3. So in other words, 4 values in our one-dimensional array which we need to initialize with emptiness, which is none. So that's what we've done for the very first row that's going to comprise our table. What we now need to do is we need to tell Python that we want the same thing for all of the other rows as well. So let's do that now. Okay, I'll just get rid of my box. So just going to do a copy and paste actually, because it's practically the same except that the variable name changes. So I'm going to put in here, okay, row 1. I need to change my comment, don't I? Create, okay, initial rows, 1D arrays with empty values. Okay, so row 1, okay, then we want row 2 to represent the third array, row in our table. Okay, we want row 4, so that should be 2, shouldn't it? Row 3, okay, and then we want row 4. So of course we have 5 rows in our table, but we've got row 4 because we've started naming them from row 0. Okay, so row 4 equals none as well. So let's just stop and pause for a minute. What we've actually done is we've asked Python to create 5 individual rows or individual arrays, all given an initial value of empty for each position in that array. What we now need to do is we need to tell Python that we want to bring those arrays or rows together to create a single table. So we're going to do that now. So I'm going to put here, okay, initialize, sorry, I'll put construct actually, because that's really what we're doing. Construct a table from the collection of rows, okay, and I put in here 1D arrays because they're the same thing, okay, one-dimensional arrays, okay, construct, there we go. Okay, so what we need to do is we need to use the same format as we did with the one-dimensional array, which is an opening square bracket and a closing square bracket. So let's do that now. I'll give it a variable name of my table. I could call it my 2D array if I wanted to as well, but I'm going to stick with the table analogy. So my table equals, and then I want a pair of brackets, an opening and a closing. Now I'm going to format on, I don't have to format it like this, but I prefer to, and I'll explain why in a minute. I'm going to format my opening and closing brackets on different lines. The first thing I need to do now is to tell Python what I want to put into my array, and of course as a table it's going to be each of the rows on top of each other. So I want to start off with row 0, comma, okay, very easy to forget the comma by the way. Row, oops, then we want row 1, of course, you know where this is going. All right, and then we want row 2, comma, and then we want row 3, and we want row 4. Oops, we don't need a comma after the last row that we specified in our table. Okay, so what I can do here is I can just pull the end square bracket up to the same line in my code. So this is the standard. It's not the only way in which we can initialize a two-dimensional array, but it's the easiest way that relates to the first video that we did when we were talking about individual rows and rows of kings. So let's stick with this method for the moment. Okay, so let's just pause and just reflect on what we've done here. We've basically said, let's create each of our rows in our table individually because they're one-dimensional arrays. So we've told Python what we want each row to look like as a one-dimensional array. Once we've done that for each of the rows that we want, we then tell Python to take all of the rows together and build a table out of them. Okay, so we should have a table comprising 5 rows, and then of course in each row we've got space or size for 4 values, and of course that is the equivalent of the number of columns that we've got. Okay, 1 value, 2 value, 3 value, 4 value. Okay, now just to prove the point, I'm going to print out our rows in a table format, but Python doesn't do that by default. Python will just print all of the rows across the table. So I'm going to force Python to do that using a loop. So I don't want you to be concerned about the syntax of the loop that I'm using if you've not seen it before, because it's not the purpose of this video to look at iteration. So I'm just going to do that specifically so I can print out the table on the screen for you. So I'm going to do 4 rows in my table. Okay, and then I just want to print the rows. So print rows. Okay. Right, let's do that now so you can see it in all of its glory as a table. Okay, so hopefully you can see here that we've got this metaphor or an analogy of a table, and what it actually comprises is rows of the table constructed by Python as one-dimensional arrays. And hopefully from viewing it this way on the screen you can see that actually that works quite well for us to stick with the table analogy for a two-dimensional array. Okay, so what we now need to do is we now need to put in some real values, and we have those copied across at the top of the screen here. So we want to put in 21, 100, 123 in the right place in the table. Now I'm only going to do a couple of these because you'll get the gist as soon as I've done 2. What you might want to do if you're programming along with me, or you could do it at a later date as well, is actually continue to program and put in the other values as well, just for practice getting the index values correct for a two-dimensional array. So let's do that now. Okay, so we want to start by allocating the value 21 in the correct place in the table. So just scroll up a little bit so we can see the picture of our table format. Rows are king, so it's row first, it's row 0. So it's row 0 here. Oops. Let's just get rid of that. Don't want that. So let's put the box back in. So row 0. So row 0 is here. Okay, and then the index position of 21 is index 1. Okay, or we would normally say column 1. So we want to specify 0, 1 to get the right position in our table to put the value 21. So it's 0, 1. So let's just get rid of my boxes and let's show you the syntax for using those two values to get the position correct in the table. So we want my table, okay, and then what we want is to specify the row first, which of course is the name of the one-dimensional array, which is 0. Okay, and then we want, in our second pair of square brackets, we want the index value in that particular row or array. And of course we said that it was 1. And then we want to specify the value that we want to assign, which of course is going to be 21. Let's do another one as well. Let's do the value 5. Okay, so there's 5. Row first, so it is row. Okay, 0, 1, 2, 3. So it's 3, and then we want the index value of the array that's at position 3. So that's 0 and 1. So we want 3, 1 to get the right place to put the value 5 into our two-dimensional array. Okay, 0, 1, 2, 3. Okay, and once we specify the row or that particular array, we want to specify the index value, okay, which is the same as the column. So it is 0, 1, so 3 and 1. Okay, let's do that now. Just get rid of my box. Okay, there we go, that's better. Right, so 3, 1, so let's pop that down as well. So I'm just going to copy and paste and change the indexes. So we want to say 3, 1. Okay, and that is going to be 5. And 3, 1 is 5. So let's do another one. Okay, let's do 97. Row first. So we have 0, 1, 2, 3, 4. So it's the 4th row. And then we want to go column 0, 1, 2, 3. So it's going to be 4, 3. So let's do that one as well. So we want 4, 3. Okay, and that I think was 97. Yep, 97. Okay, and let's print it out again once we've made those changes. So I'm going to copy my iteration syntax. Okay, well, that should be 97, shouldn't it? I beg your pardon, 97. Okay, so I want to print an extra row just to split out two table prints. So I'm just going to put print empty line there as well. Okay, so we should have a before and after. So let's do a before and after then. And we can see here, here's our before. Okay, so here's our two-dimensional array, all with initial empty values. And now you can see that we've specified 21 at that position. So that's correct. We've got it in the right position there. So that's row 0 at position 1. We should have 5 here. So we've got 5 there. So that's correct. Okay, and then we should have 97 at the bottom, and we've got 97 in the bottom corner. So that's worked fine as well. So just to summarize then, the way that we, or the syntax that we use to be able to access and allocate particular values in a two-dimensional array is to specify the row first and the column second. And recently we've done 3 examples of that where we've assigned a value using the row first and the column second. And just by way of a reminder, let me just get my marking tool out. We said that we wanted to allocate 21 at row 0, so that goes in the first set of square brackets, and followed by our column, which was column 1, and that goes in the second pair of square brackets. The brackets go back to back. And let's just check that 21 was indeed at position 0, 1. So let's just get rid of those. 21 at 0, 1 is, there we go. So we have row 0 and then we have column 1. Okay. So I'm sure you appreciate by now that imagining or picturing a two-dimensional array as a table where we can work with individual values in terms of the row and the column is very, very powerful. And in fact, that's all you need in terms of getting the syntax correct for being able to work with individual parts of our two-dimensional array. And you can see we've done 3 examples of that where we very simply just specified the row followed by the column. But in addition to that, it's also important to appreciate that the way that Python constructs a two-dimensional array is that essentially each row is an individual one-dimensional array, and the column in the table is the equivalent of the index position in that particular one-dimensional array. And if you can work with both of those concepts and work with them confidently, then you will be in a very, very good position to do more challenging work with two-dimensional array data structures. So that brings me to the end of this video. We've looked at constructing and initializing a two-dimensional array. We've kept the analogy of the table with rows and columns going as well, because that's very, very useful. But I hope you've also appreciated that from the Python perspective, a two-dimensional array is actually constructed from individual one-dimensional arrays, where each one-dimensional array essentially is the equivalent of a row, using our table metaphor, if you like. So in the next video, I'm going to show you how to iterate through the entire contents of an array, to search for particular parts of an array, and for example, to be able to extract a particular row or a particular column, depending on what the user is searching for. So I will see you in the next video.